Hello and welcome to the session on numeric types in Python. There are three kinds: int, float and complex. Let's see how they work. So in the first cell we're going to assign variables to one of each kind. And then let's see what Python throws up when we try to type these values. So if we're going to print type of x, y and z, we get these three classes in return. So x is equal to 1 here. It's returned a class int. Int stands for integer. Y is equal to 2.8, which is returned a class of float. And z is equal to 1j, which is returned a class complex. Let us go over each of these types one by one. Now we have some information here in the sheet, and you will have access to these notebooks also, but you can pause the video at any point of time if you want to read and then proceed. Now integers are whole numbers. There are no fractional parts. They can be negative or positive, so they extend from minus infinity to plus infinity. The only criteria is we cannot have a decimal point. So 1, 2, 3, minus 4, minus 5, all these are integers. Integers are used over and above other kinds of data types, which are called floating point data types. Now floating type data points are the numbers which have got a decimal value in them. This is because they are represented as floating points in the computer's memory, and there are conventions for that if you have studied computer science. Floating points are more efficient way of representation of a number. It's composed of two parts, a mantissa and an exponent, and this makes for more efficient memory representation. Again, in floating point numbers, we can have any range of numbers. Let's take a look. So we have we'll come here. X is equal to 1.10. Because it has a decimal, it's a floating point number. Y is equal to 1.0. Now actually the value of y is 1, which is an integer value. But because we have specified 0.0, Python will take it as a floating point number. And then a negative floating point number. If we ask Python the data type of these three variables, let's first run this cell, and then we ask Python to identify them. It's going to come up with float for all of them. Now you can also use the letter E to indicate exponent. E stands for exponent, and if you specify a number such as this, x is equal to 35e3, it means that we take 35 and multiply it with 10 to the power 3. So this number is going to be 35,000. However, because we have used exponent, it's going to be represented in memory as a floating point number rather than an integer. So let's try and run these three cells and see what comes up. So all these numbers are floating point numbers. I would also like you to take a look at what x actually looks like without the e. So if we ask Python to print out x, it prints out 35,000.0. So this 0.0 is added because of the fact that we've used an exponent here. Now these are numbers, integers and floating point numbers that you have come across in your daily life. Complex numbers are something which we normally do not encounter, and complex numbers came into being because there was an issue of representation of square roots of negative numbers. So we know square root of 4 is 2, plus and minus 2, but what happens when we take the square root of minus 4? So to deal with this problem, minus 1 was separated out, so we take it as square root of minus 4 being equal to square root of 4 multiplied by square root of minus 1. And then we can take 2 as the square root of 4. Under root of minus 1 is identified as iota or I, written in many texts as I. But in Python we use the letter J to represent complex numbers. So we have to have two components of a complex number. One is a real component. So in this example 3 is the real component, and 5 times J or 5 times iota is the imaginary component. So if we run this cell and then we ask Python to print out what kinds of numbers these are, it's going to say complex numbers. Complex or imaginary, that's the same thing. Now Python also allows you to convert a number from one to another type, and many a times it will also do it behind the scenes as well. So for example, if you say take two integers 4 and 2 and say divide 4 by 2, then Python will return 2, which is another integer. But if you take 3 and 2 and ask Python to divide 3 by 2, it's going to return 1.5. So it's going to automatically convert it into a float where it feels the need to do so. it prefers to deal with integers in terms of memory, but it will Python will always take care of the accuracy for you. Now let's see how the numbers are converted. These are three numbers: x is equal to 1 being an integer, y is equal to 2.8 is a floating point number, and z is equal to 1j is a complex number. Let's run the cell. Now we are going to convert from integer to float. So we are having a new variable a, and we are going to say take the number x, which we know is integer, and convert it to a floating point number. So let me run the cell. I've done this. Now how to look at it here, I will come to this point later. First, let's also convert a floating point back to integer. So we're going to take y, convert it to integer by passing it through int. Run this cell, and now we're going to convert integer to a complex number like this. So these are the functions we use. Now let us print out these values and see what happens. The first one, a, we had 1, and by converting it to a floating point number we got 1.0. So Python added the decimal and the 0. The difference is in the memory storage of this number. Instead of being stored as an integer, now a is being stored as a floating point number. For y is equal to 2.8, when we converted it to integer here, Python just got rid of the decimal, because integers do not have decimals. So Python doesn't do any fancy processing, it just gets rid of the 0.8 part of it, and we are left with 2. Finally, for a complex number creation, we are trying to convert c as a complex number derived from x. So x was 1, that was our integer. We made it as a complex number. So the 1 here is the real part which we get from x. 0j means that we did not really supply any complex or imaginary part to it. So that is represented like this. But the whole number now has become a complex number because of the addition of this j element. The issue with complex numbers is that you cannot convert complex numbers back into a different number type. So you cannot have a complex number and say I want to make an integer or a floating point out of it. Let's convert these numbers, the types of these numbers, and see what Python comes up with. So this indicates that our conversions were successful. We got converted an integer into a float into an integer, and an integer into a complex. All three were good. Now let's come to random numbers. Now Python doesn't have any random number function per se. However, there is a library called random. So we can use that library. We just say import random, and then using a function, there are several functions in that library, we can print out our random numbers. So here we're going to use a function called randrange from the random library. Now randrange function takes a set of numbers. It takes a start number and an end number, and it's going to use a pseudo random number generator internally and give us one number out of this range. Let's take a look. If we run the cell, we get the number 1. Now because these are random numbers, or technically speaking these are pseudo random numbers, every time we run the cell we're going to get a different number. So if you are wanting to create a game based on chance, for example a poker card game or something, then you might have use for random numbers. They are also used in machine learning quite a bit because we want to randomize the data before we do any analysis. So that's it for the numerical data in Python. I hope you enjoyed the video. Thank you, and we'll see you in the next one.